right, lesson 4 is about the angles in a polygon. So just like a triangle has 180, a square or a rectangle has 360, how can we predict, say, a 21-sided object? How can we get how many angles are in it? And so there's this little, let's talk about a couple things. Remember what a regular polygon is. A regular polygon is what has all sides and angles are equal. All equal sides and angles are equal. So an example of a regular triangle would be an equilateral triangle. An example of a regular rectangle would be a square. Okay, a pentagon with all equal angles and sides would be a regular pentagon. All the angles and all the sides are equal, then it's regular. So here's a little investigation, and they started off. So what we're going to do is we're just going to do the pentagon. And so here we have a pentagon, and so it's been inscribed in a circle, and in the center of the big pentagon, they draw a line to touch each different vertice. Okay, so we know that this full circle here is 360 degrees. Now, because it's inscribed on a circle, we know that each one of these are the radii. It's a radius. Because this center of the pentagon is the center of the circle, meaning that each one of these triangles is an isosceles triangle. So this angle here is equal to that angle there because it's an isosceles. So let's start off with number of sides. How many sides does a pentagon have? It has 5. So if we break it up into 5 different triangles, the question is how much is each one of these if they're all the same? If we know the full thing is 360, if we divide it by 5, then we know each one of those little angles in between is 360 divided by 5. So grab your calculator, 360 divided by 5. And our answer is 72. So each angle in between are 72 degrees. So here's 72, here's 72, 72, 72, and 72. They're all 72. Okay? Now for the sake of space, I'm just going to write one of them as 72 degrees. So 72. Now we talked about how each one of these are a radii, right? And so these angles are equal. And if we know it all adds to 180, if I take 180 degrees and I take away my 72, that's going to give me how much? 180 minus 72. 108. Now we know 108 degrees is the sum of those two, and if they're equal, we can divide that by 2, giving 54 degrees each. So 180 minus 72 divided by 2 gives us each a 54-degree angle. So each one of those little angles here are 54 degrees. Now, because it's regular, all these little triangles are the same, meaning that this angle is also 54 degrees. So if we know that each of them are 54, then how can we get that full angle of the pentagon? Well, 2 times the 54 degrees, which gives you 108 degrees. And so 108 degrees, we know there's 5 different sides, and they would each be 108. So all 5 of these are 108 degrees, so times it by 5, and that's the number of the total degrees in a pentagon. So 540. Okay, so let's do the general case. So we're going to skip the nonagon and dodecagon, so 9 sides, and go to n side of polygon. So if we have n sides, and it doesn't matter what we have, so we have n sides, and we want to figure out, okay, if there's n different triangles, then how do we get each angle in here? Well, 360 is a full circle divided by n triangles. Divided by n triangles. Now we know each angle, right? So if we had each one of those triangles, this is 360 divided by n different triangles, because there's all these different triangles, right, in our shape that's inscribed in a circle. So again, how do we get this side here and that angle there? Well, if we know this is 360n and these two are equal to each other, then we take 180 minus this 360n over n, and then divide that all by 2. Now that looks really ugly, really, really ugly. So if I simplify this, it would actually be 180 over 2 minus 360 over 2n. Over 2n. Oh, sorry, no. Yep. So then we simplify that even further. So we divide each one by 2. It'd be 90 minus 360 over 2 is 180 over n. So I just simplified 360 divided by 2 is 180, and then the n still in the bottom. So that's the simplified form of this box here. It's 90 minus, so each one of those angles right here would be 90 minus 180 divided by n sides. So then we said, okay, well, we knew that was for one, and then we know there's another triangle here, and it's going to be identical. And so double would give you that whole angle. So if we double this, 2 times that, so it'd be 180 minus 360 over n. If we double it. And that was the degrees of each interior angle. Okay? And then we said, okay, well, if there's n different sides, we just took the number of sides times each angle is 90 minus 180 over n. So when we distribute that, we get 90n minus 180 oh, sorry. Each angle was 180, not, was right the previous step. 180 minus 360 over n. So we're going to distribute that. So there, each angle is that. There's n different angles. So the total number of angles would become 180n minus, when you multiply 360 over n by n, the n's cancel out, so 360. And so if we factor out 180, we get n minus 2. So this is basically the proof that the total sum of our angles in a polygon is 180 times n minus 2, where n is the number of sides. So just to check, let's try our 5 sides. So if we have 5 sides, then n equals 5. 180 times 5 minus 2 is equal to 180 times 3. If you grab your calculator, 180 times 3, 180 times 3 gives you 540, which is what we had before. And so that is, I believe, on your formula sheet, but you also should know it, that the total angles in any n-sided shape is 180 times n minus 2. So a triangle was at 180 times 3 minus 2, or 180 times 1, which is 180. So let's move on. So another way to prove this is constructing triangles, right? We know a full triangle has an 180 degrees. So if we draw like a diagonal through a 4-sided shape, we know these 3 would add to 180, and these 3 would add to 180. So together it would be 360 if we add 180 plus 180. So again, if we take the vertices and we make triangles, again, the triangles cannot overlap. We have here the first triangle would be 180. The second triangle here would be another 180. And the third triangle is, again, this angle, this angle, and this angle. Notice that all these angles that we've drawn will total up to all the angles in our n-sided shape. So 180 times 3, and notice this was a 5-sided shape, is 540. Okay, and our previous page we proved that it would be 180 times n minus 2, which is 180 times 5 minus 2. So another way to prove this. So if, say we have an n-sided shape like this, and you want to figure out, okay, how many degrees? Well, you could either use the formula, 180 times n minus 2, or we can make triangles. So I start with this vertice, and I'm going to move over. And it doesn't, like we could go, okay, now I'm going to go down to this vertice. You can do like a zebra print. The key here, so lines cannot overlap. We want to make as many triangles as possible with every vertice. Okay, so there, how many triangles we count? 1, 2, 3, 4, 5, 6. How many sides does this have? 1, 2, 3, 4, 5, 6, 7, 8. So notice there's a pattern. We're always going to have 2 less triangles than the number of sides. So 8 sides, we had 6 triangles, 180 degrees each times 6 gives us our total degrees. 180 times 6 is 1080. So this would be 1080 degrees total for all the angles inside. Let's try another one. So let's make triangles. So 1, you could even do all from that one point to start instead of a zebra type pattern. So that point to each vertice. And there you go. And we count our triangles. 1, 2, 3, 4, 5, 6, 7, 8. Which if you counted the number of sides, would be 10 sides. Remember, we're going to have 2 less triangles than the number of sides. 180 degrees for each triangle times 8 triangles gives us, grab your calculator, 180 times 8 is 1440. 1440 degrees. Okay. So let's fill in the pattern. When we had 5 sides, so up above, when we had 5 sides, how many triangles did we have in this case here? 1, 2, 3. There's 3 triangles, and so we did 180 times 3, which gave us 540. When there was an octagon, 8 sides, how many triangles did we have? 6, 2 less. So 180 times 6 gives us how many? 180 was 1080 degrees. And we had our decagon. Our decagon, we had 10 sides then. We had 8 triangles. So 180 times 8. And that gave us 1440. So let's, if there was 100 sides, if we had 100 sides, how many triangles could we make? It'd be 98. So our total degrees would be 180 times 98. Now that's going to be a large number. So 180 times there's 98 different triangles, 17,640 degrees. So if there's n sides, how many triangles can you make? N minus 2, 2 less than the number of sides. And then we take our total, or 180 degrees in one triangle times the number of triangles. And that's just like the previous page, so proving that again. So this you really need to know. So the work on the previous page shows that the sum of the measure of interior angles of an n-sided irregular polygon, meaning all the sides don't have to be the same, or angles don't have to be the same, but the total angles, if you have n sides, is 180 times n minus 2. Okay, so this theorem right here is super important. The sum of the interior angles of an n-sided shape is 180 times n minus 2. Now just a little extension of what this means right here. Okay, you can ignore this. It's just another way to write it. Kind of looks more confusing. If you know you have a regular polygon, so remember in a regular polygon, all angles are equal. All angles are equal. You can deduce very easily what each angle would be. How? Well, remember that 180 times n minus 2 is the sum of all the angles, sum of all interior angles. Sum of all angles. And if we knew the total sum and all the angles are the same, and we divide it by the number of angles, or sides, which is the same as the number of angles, we could get how much each angle is. So if I know that in a regular pentagon, there's 540 degrees, well then each degree I just divide it by 5 to find out how much each one is, 108, each interior. So if you know the total sum, divided by the number of sides, we have each angle. Only if it's regular, only if all angles are equal. The little extension is you need to know what an exterior angle is. So if they ever give you an exterior angle, you need to know this property here. So basically, if one of the lines, so here's my pentagon or whatever this is, I'm just drawing it here, and they extend one of the lines or both of the lines, right? Any of the lines, if they extend one of them and they give you an exterior angle, all it is to get the interior angle, we do 180 minus that. So if this exterior angle was 50 degrees, then the interior angle would be 180 minus 50 or 130. And so whenever they give you a problem, if they give you the exterior angle, and you can ignore this stuff, just if they give you the exterior angle, we just subtract it from 180 to get the interior angle and we'll be good. Okay, so you ignore this theorem. What you really need to know is to get your interior angle, we just use 180 minus the exterior. So let's look at a couple examples. All right, calculate in degrees the sum of the measure of interior angles of a polygon with n or 9 sides. So our formula, which you should get in the habit of writing out, is the sum of all the angles is equal to 180 times n minus 2. 180 times n minus 2. So if you have that on your formula sheet, you know that, then we can just substitute and solve for whatever it is we're looking for. So the question is, did they give us the sum or did they give us n? Tell us there's 9 sides, that means n equals 9. N is the number of sides. So to get the sum of all the angles, it would be 180 times 9 minus 2, or 180 times 7. And so our sum would be, grabbing your calculator, 180 times 7, 1260. So 1,260 degrees. Pretty simple. This determine the number of sides of a polygon whose interior angle sum equals 4,140. So what's our formula? The sum is equal to 180 times n minus 2. So they give us the sum. So we're going to sub in our sum as 4,140 is equal to 180 times n minus 2. Now we can expand that, like use the distributive law first. That might be a good place to start. And that's probably where a lot of you would start in solving this. We have two options. We can start by dividing by 180, or we can get rid of the brackets first, because we need to isolate n. So let's get rid of the brackets. So 180 times n is 180n, and 180 times negative 2 is minus 360. Now we want to isolate n, so what's the first thing we want to move, the 180 or the 360? And the answer is the 360. We want to take care of the subtraction before we can divide. So we have a minus 360. We're going to add 360 to both sides. This will allow this to cancel out. And so 4,140 plus 360 is 4,500 equals 180n. And now we have 180 times n, so we can divide by 180. And let's see, where's our calculator? 4,500 divided by 180 gives me 25. Now, if you get a decimal, did you make a mistake? And the answer is yes, because we're looking for the number of sides. And the number of sides is always going to be a natural number, right? Natural numbers are counting numbers. You can't have a decimal. So n, you have n 25 sides. And there's our solution. So let's look at the next one. Determine the number of sides, so we're wanting n, of a regular polygon. Ooh, that's important to know, because all the angles are equal. Whose interior angles measure 170. Interior angles equal 170. Now, there's a formula we learned about before, right? We know if it's regular, all the angles are equal. And so if all our angles, the sum of all the angles is 180 times n minus 2, if we divide that by n, that gives us each angle in the regular polygon, right? Each interior angle. So the interior angle in a regular polygon. the interior angle in a regular polygon is equal to 180 times n minus 2. Okay, so if you're looking, we know that the interior angle, each interior angle is 170, and we get that by taking our total divided by the number of sides. So we have to solve for n here. So our first step is to get n off the denominator, and how are we going to do that? We need to multiply both sides by n. That's our first step. So we have 170n equals 180 times n minus 2. Now what? Well, let's get rid of those brackets. We need to solve for n, so get rid of the brackets. 170n equals 180 times n is 180n, and then 180 times negative 2 is minus 360. So here's our problem. We want to collect like terms. I have n's on each side of the bracket. So we need to move all the n's to one side and all the angles to the other. So the easiest way to do that is subtract 180 to both sides, 180n. Okay, then we move all our n's to one side. So 170 minus 180 is equal to negative 10n, and that's going to equal to negative 360. Don't worry about the negative. It should cancel out in the end here. We have negative 10 times n, and I want to get rid of the negative 10. We're going to divide. Opposite operation. These cancel, and look at that. The negatives cancel, and 360 divided by 10 is 36. There it is. So you shouldn't get a decimal, and we shouldn't get a negative number here, because we're looking for the number of sides. And there'd be 36 sides. Okay, let's try number 4. Determine the number of sides of a regular polygon. So we want n, and it's regular, so all the angles are equal, whose exterior angle measures 60. Well, we want interior angles. So how do we get our interior angle? Well, remember, our interior angle is equal to 180 minus the exterior angle. So what's our interior angle then? 180 minus 60. So each one of them are 120 degrees. And so we know each angle is 120. We don't know the sum, right? We know the sum is always equal to 180 times n minus 2. We know each angle though. So this is similar to the above. And so when each interior angle in a regular polygon is equal to 180 times n minus 2 divided by the number of sides. So the total angles divided by the number of sides. So how much is each interior? Each one is 120. Okay, so let's solve for n. So first step, we have to get the n off the bottom, times both sides by n. 120n equals 180 times n minus 2. Solving for n, we need to get rid of those brackets first. 120n goes 180n minus 360. I want to bring all the n's to the same side, so subtract 180n. That's going to give you negative 60, just moving up over here. Negative 60n equals negative 360. And then last, we divide by negative 60. Okay, so if you have your calculator, negative 360 divided by negative 60, negative 360 divided by negative 60 should be 6, right? 6 sides. So n equals 6. And last example here. So determine the value of x and a in the diagrams below. So the question here is, we need to figure out what all of these angles are adding to in order to figure out what x is. So how many sides does this shape have? Well, it has 6 sides. So what's the total sum of all the angles? Remember, the sum is equal to 180 times n minus 2. And in this case, what's our n equal? Number of sides is 6. So 180 times 6 minus 2, or 180 times 4. Make sure when you type this in your calculator, it's really important, if you want to type it in as you see it here, you add those brackets. Because if you don't, then your calculator is going to multiply by 6 and then just subtract by 2. That's not the same thing. Or you can subtract the 2 first, so go 180 times 4. So 720 degrees. So now we can find x. right? We know that all of those angles are going to add to 720. So we can just take, we know x will equal to 720 minus the sum of all these. You can add them together first if you want and then subtract. So if we add these together, we have 110 plus 120 plus 125 plus 115 plus 130. So those sum to 600. So 620 minus the 600 gives you 120 degrees. Okay. This one's interesting. There's supposed to be an arrow here. That arrow is pointing to this part right here. And this arrow is that part right there. And they want us to find A. Okay. Now, how many sides does this have? 1, 2, 3, 4, 5. The polygon has 5 sides. Okay? N is equal to 5. Now, if they give us A plus 20 is this angle, how could I get this angle right here? Can we get that angle right there? Angle B, we'll call it. Well, remember, it's a straight line, so angle B is going to be 180 minus, make sure you put this in brackets, A plus 20. When we subtract this whole thing, you have to distribute that negative. So we get 180 minus A minus 20. Because we're going to distribute that negative to each one. It's like we're changing it to addition by making both those negative. And so 180 minus 20 gives you 160 minus A. And so angle B is equal to 160 minus A. Now, if there's 5 sides, we can figure out what A is because we know what the total sum is going to be, right? How do we do that? Well, if the sum of all our angles is always 180 times n minus 2. So our sum is going to be 180 times 5 minus 2, or 540. 540 degrees. And so how can we figure out what A is? Well, if we know these are all going to add to 540, let's add them together. So A plus 12 plus 3A plus our B, which was, in terms of A, 160 minus A. Add our angles in there. There you go. Plus 2A plus 3A minus 4. Minus 40, sorry. So let's collect like terms here because we're just adding. So our A's, we have 1A plus 3A is 4A, minus an A is back to 3A, plus 2A is 5, plus another 3 is 8A. So equals 8A. And let's add the other guys together. 12 plus 160 is 172, minus 40 is 132. Okay, now we've made this a lot easier. Let's solve for A. So we need to bring all the constants together and do that by subtracting 132 to both sides. That's going to give us 408. 408 equals, scroll down here, equals 8A, and then last divided by 8. So 408 divided by 8 gives us 51. So A is equal to 51. There we go. Now we're done. All right, so the assignment for this one is 1 through 10.